So on today's tutorial we will be making an object detection web application. We will be detecting tumors on a brain MRI image. Now let me show you how it works. I'm going to drag and drop an image from my computer. So this is the image we have uploaded, and if I click here on detections, you can see that we have detected two objects, we have detected two tumors on this image. So this is exactly a project in which we will be working today on today's tutorial. We are gonna make the entire web application using Python and Streamlit, and we're gonna detect objects using an object detector trained with Detectron2. So my name is Felipe, welcome to my channel, and now let's get started. So let's get started with this tutorial, and the first thing we need to do is to create a new PyCharm project. You can see that this is PyCharm, and now let me show you how to create a new project. We need to click here on new project. I'm going to select the directory where I'm going to create this project, which in my case is here. And then I'm going to select tutorial. This is the directory in which I'm going to create this PyCharm project. And then I'm going to create a new environment, and the interpreter will be Python 3.8. Everything else will be just the default values. I'm going to click on create, and that's pretty much all. Now the next step will be to install all the requirements we are going to use today. So I'm going to create a new file which is called requirements.txt. I'm going to name this file requirements.txt. I'm going to press enter, and then I'm going to paste all the requirements, all the dependencies we need to install in this project, which are all of these packages we have over here. So I'm just going to copy and paste these packages over here, and that's pretty much all. Now I'm going to the terminal, and I'm going to press pip install -r requirements. And that's pretty much all. I press enter, and that's going to take care of installing all the requirements. And you can see that I got an error, and basically this error is because we need to install all of these dependencies first, and then we need to install this final dependency, right? You can see that this one is called Detectron2. We need to install everything else first, and then at the end we need to install Detectron2. So I'm just going to comment this line, and then I'm going to press pip install -r requirements again. Okay, now all the requirements have been installed, and now the only thing we need to do is to install Detectron2. So I'm going to uncomment this line, and I'm going to press pip install -r requirements again, and this is going to take care of installing all the requirements. But as we have already installed all these packages, the only one that's going to be installed now is Detectron2. So we need to wait a few minutes. Okay, and that's pretty much all in order to install Detectron2, and now we are all set. All of our requirements have been installed, so it's time to continue. Let me show you how to create a new file. Let's create a new Python file, so we're going to select File, New, Python file, and this file will be main.py. So this is the file in which we are going to be coding the entire web application of today's tutorial. And remember, in this tutorial we are going to be detecting tumors on brain MRIs. So we definitely need an object detector in order to detect this type of objects, right? Let me show you the data I used in order to train this object detector. This is a dataset I found in RoboFlow, and I'm going to give you a link to this dataset in the GitHub repository of today's tutorial, so you can just go ahead and take a look at this dataset if you want to. And this is an object detector I trained using Detectron2. And I'm not going to show you the details of how I trained this object detector, because that's something I have already covered in one of my previous videos. In one of my previous videos, I show you how to train an object detector using Detectron2, and I show you the step-by-step guide. I show you the entire process. So if you are curious to know how exactly I trained this object detector, I invite you to take a look at the video I'm going to be posting over there. And now let's continue. This is the data I used in order to train this object detector, and now let me show you the entire pipeline in which we are going to be working today. Let's get back to PyCharm, and let me show you exactly what are all the steps we are going to be making in this tutorial. The first step will be setting up the title of the web application. So this is the first step in this process. Then the next step is setting up the header, right? The third step will be creating a file widget upload file so the user can upload an image about a brain MRI so we can detect all these objects on top of this image. Then the next step is loading the model, right? Loading the object detector we are going to be using to detect objects. Then we are going to load the image the user has uploaded. Then we are going to detect objects. And then the last step in this process will be to visualize the objects we have detected on top of the original image, and we are just going to display this visualization to the user, right? So these are the steps of the entire process, the entire pipeline in which we are going to be working today, and I'm going to show you every single step of this process. So you can see these are 1, 2, 3, 4, 5, 6, 7 steps. In only 7 steps we will have this web application up and running. So let's get started. And the first step in this process is importing Streamlit as st. Okay, then in order to set up the title, I'm going to call st.title, and the title will be something like brain MRI tumor detection. Then in order to set up the header, I'm calling st.header, and this will be something like please upload an image. Okay, then in order to create the file upload widget, I'm going to call st.fileuploader, and I'm going to input 2 parameters. The first one is an empty string, and then it's all the types we support in this widget, and I'm going to say something like PNG, JPG, and then JPEG. Okay, and that's pretty much all. And in order to move one step at a time, let's see if everything executes just fine. I'm going to execute the code as it is so far. So I'm going back to the terminal, and I'm going to type streamlit run main.py. This is going to open my browser, and we are going to see exactly what our web application looks so far. And everything looks just perfect, so we are okay in order to continue. So let's get back to PyCharm and let's continue with the next step in this process, which is loading the model, loading the object detector we are going to be using today. And remember, we are going to be using an object detector which I trained using Detectron2. And remember, I already showed you how to use Detectron2 in one of my previous tutorials. So let's go back to my browser and let's see exactly how we can use this model which I trained with Detectron2. Let's go to the GitHub repository of this previous tutorial and let's see exactly how this training this model or how using this model was all about. So I'm going to this file over here, which is predict.py, and this is the file we use in order to load the model, in order to make predictions with a model trained with Detectron2. So the only thing I'm going to do in this tutorial is to copy some of the code in this file, and I'm just going to paste it in the main.py file of our PyCharm project, right? Remember that in this tutorial we are not going into the details of how to use Detectron2, so I strongly recommend you to take a look at my previous video, to take a look at this video over here, which you are going to find in my YouTube channel, so you can see exactly how this using this model, how using Detectron2 works, right? Because we are not going into the details in this tutorial, right? So this is my strong recommendation for you. Please take a look at that previous video. The only thing we're going to do now is just copy and paste some of these lines, which I'm going to explain super quickly. Right, you can see that we are getting a configuration file, then we are getting the weights for this model, and we are getting the weights from this model from our local drive. So we are specifying a file path allocation in our local drive, and the only thing we're doing is specifying the weights location. Then we are creating an object which is our predictor, and this is exactly the model we need in order to continue with this process. So this is a very quick explanation regarding this code we have over here, and now let's continue. Now you can see that we need to make a few imports because we are not finding these objects we have over here, these functions we have. So I'm going up, all the way up, and I'm going to say something like from Detectron2 dot config import get config, and that should be all for this function we have over here. Then from Detectron2 dot engine import default predictor, and that should fix this issue over here. And now we need to import from Detectron2 import model so, and that should be all in order to fix this issue over here. I'm going to delete these comments, and that's pretty much all. So everything that's here is everything we need in order to load this model, but obviously we need a model in order to load, right? Because this is just the default code we had in our GitHub repository. So let me show you exactly where it's my model in my local drive. If I go to my file system, you can see that I have this file over here, which is model.pth, and I have this other file, which is label.txt. This is the model we need, model.pth. These are the weights of our model. And then what I'm going to do is to copy this file, and I'm going to paste it in the directory of this Python project, right? You can see that this is the main.py in which we are currently working in. This is the requirements.txt file we created a few minutes ago, and this is exactly where I'm going to paste this model. And I'm going to do something else, which is creating a new directory which is called model, and this is where I'm going to put the model, and everything it's okay. And remember, I show you we had another file which is all the labels we are detecting, but in our case this is a very dummy labels.txt file because we only have one category. We are only detecting one class, which is tumor. And a very quick note is that remember the dataset I used in order to train this object detector. In this dataset we had two classes which were negative and positive, and this is something like two different types of tumors, or that's what I think. But what I decided to do when I was training this object detector was merging these two labels, these two categories, into only one object, and I called this only one object. I call it tumor, right? So that's exactly why we have only one class over here, given that although the original dataset I used had two categories. So that was a very quick note regarding the model I trained, and now let's go back to my file system. We are not going to use this directory anymore. I go to model, and this is the model we are going to be using. This is the weights, the model weights we are going to be using. So remember, this is within another directory which is called model. I go back to PyCharm, and the only thing I'm going to say is something like model, and then the name is something like model.pth. Okay, and that's pretty much all. In my case, I'm going to run this code in my local computer, which is using a CPU. So this is what I need to specify. If your computer or the computer where you are running this code has a GPU, then the only thing you need to do is to comment this line, and everything will run on your GPU. But in my case, I'm going to run it locally on my CPU, so I'm just going to leave this line as it is. Now let's continue. Now it's time to load the image we are going to use in order to detect all these objects. So this is what I'm going to do. If file, I have to make another edit. So we are uploading a file, and we are calling the file the user has uploaded. We are calling this object file. So now if file, so if the user has uploaded something, we are going to continue, and we are going to call the image. We are going to call this object, we are going to call it image, and then image will be image.open file, and then something like 2RGB, right? An image is an object we are going to import from pillow, right? From pill import image. Okay, that should be all. Okay. Now, in order to move one step at a time, let's go back to my browser and let's see if everything executes just fine. I'm going to refresh, and everything is just fine. And now I'm going to select an image. Let's see if everything's okay. The data I'm going to use, it's located over here. This is train and val. I'm just going to select a random image, which is this one. And let's see what happens. We have an error because this is not called to. but this is called convert, if I'm not mistaken. Let's see now. I'm going to refresh and I'm going to do the same process again. I'm going to select the same image and I'm going to drop it over here, and you can see that now we have another error because it's not convert but it's convert. I had another typo. Okay, now let's see what happens. I'm going to refresh again. Let's hope everything is okay now. I'm going to take the image, I'm going to drop it here, and let's see what happens. Now we have to wait a couple of seconds. We may be loading the model, so this may take a few seconds and everything is okay. We are not visualizing the image, so if we are not getting any error, that means everything is okay. So let's go back to PyCharm. Everything is okay so far, and now it's time to detect objects. We are moving super quickly. We are almost there, right? We have almost completed this process, this pipeline, and the only thing we need to do now is to detect objects. And in order to detect objects with this model, which was trained with Detectron2, I'm going back to my browser and to this repository because let's see exactly how we can make this prediction. The only thing I'm going to do is to copy and paste everything that's from here up to here. We don't really need to draw the rectangle, but let's just copy everything. So I'm going to copy, then I'm going to PyCharm, and I'm going to paste it here. We will need to make a few edits, but most of the code will remain the same, right? I'm just going to fit this image over here because if I go back to my GitHub repository, you can see that this image is actually a numpy array, right? We are reading this image using OpenCV, so the format is a numpy array and we need to input a numpy array over here. So I'm going to do something like, I'm going to define another variable which is image array, and this will be numpy as array image, right? We will need to import numpy, so I'm going to say something like import numpy as np. And that's pretty much all. Now I'm going to input image array, and that should be it. So this is pretty much all. We are going to be detecting all the objects we have. We are going to be returning all the objects we have detected with a confidence value greater than 50%, and other than that, everything is just fine. And that's it. And we don't really need to draw the rectangle, so I'm just going to delete it. And that's pretty much all. So we have loaded the image, we have detected all the objects on top of this image using our model, and now it's time to continue with the visualization. Now we are going to take all the detections, all these objects we have detected, and we are going to draw bounding boxes on top of the image the user has uploaded. So this is amazing because we're moving super quickly, and let's see how we can continue with the visualization. Now it's the time in which we are going to draw bounding boxes on top of our images, and in order to do so we are going to use Plotly. Plotly is an amazing Python library which I have used many times in my projects. It's an amazing library. You can do some very crazy visualizations using Plotly, some very dynamic visualizations. So this is a very amazing library we are going to use now. And something that's very important is that in my tutorials, we always focus on the computer vision part of the problem, and everything that's related to the visualization is not really that interesting from a computer vision perspective. So what we are going to do now is just taking the code for the visualization, which I have already prepared over here, right? This is a function which is called visualize, and this is a function we are going to use in order to visualize the bounding boxes on top of our images. So please pay attention, please focus, because otherwise you may be lost. Please take a look at what we are going to be doing now. I'm going to the project, I'm going to file, new, Python file, and I'm going to create a new Python file which is called util.py. Then I'm going back to this file I have over here, and I'm just going to copy the entire file. I'm going to press Ctrl C, and then I'm going to press Ctrl B over here. So this is all the code we need in order to do the visualization. Remember, the visualization is very interesting and very important, but it may not be the most interesting thing from a computer vision perspective, and that's why we are not really minding everything that's visualization, everything that's related to how to visualize all these bounding boxes on top of the images. We are just going to use this function, and that's pretty much all. I need to do a few imports, otherwise this is not going to work. I'm going to import Streamlit as st, and that's pretty much all if I'm not mistaken. Yeah. Now let me show you something which is related to all the code I have just copied. You can see that this is the code of two different functions, right? One of them is called visualize, and this is a function we are going to use now in a few minutes in order to visualize all the bounding boxes on top of our images, and the other function is called set background. And this is another function which is only going to make a very small and a very static detail at the end of this tutorial, which is changing the background of the web application, right? This is only a detail. This is definitely not the most important thing from a computer vision perspective, right? This is just changing the background of the web application of the browser. So this is something we are going to do at the end, and this is also in the code I have just copied and pasted into this file. But now let's focus on this other function, which is visualize. You can see that this function receives two parameters. One of them is image and the other one is bounding boxes. And you can see that the images are the input image, and then the bounding boxes are a list of all the bounding boxes in the format x1, y1, x2, y2. So now let's go back to main, because let's see exactly how we can call this function over here. The first thing I'm going to do is from util import visualize, right? Now the function is imported into our main process. And now let's go back here, and then this is where we are going to call this function. Remember, we need to input two parameters. One of them is the image we are going to import, the image we are going to use in order to draw all the bounding boxes, and we need to input the image in the pillow format, and then the other variable is bounding boxes, right? B boxes. And please focus and please pay attention, because we already have a variable which is b boxes. But if we go back to the documentation, you can see that this variable is a list of bounding boxes in the format x1, y1, x2, y2. So this is not the same as this other variable we have over here. Please pay attention, because otherwise it may be a little confusing. So this is what I'm going to do. I'm going to define a new variable which is bounding boxes underscore. This is going to be a list. And what I'm going to do here is just appending the bounding boxes exactly as we need them to be, right? So this is what I'm going to do, and if I go back to util.py, this is exactly what we need to input. Okay, so we have this object over here, and the only thing I'm going to do is to paste this object over here. And I invite you to take a look at this file. I invite you to take a look at this function, visualize, so you can see exactly how it works, and you are going to see exactly we are using the plotly library, and we are calling some functions, and we are doing some stuff which is related to visualization, right? I invite you to take a look at this function. This is going to be available in the GitHub repository of today's tutorial. But now let's continue and let's see exactly what happens if we refresh this website and if we upload a new image, and let's see exactly what type of visualization we will be getting with this function. So I'm going back to my local computer, to my file system. I'm going to take a random image again, and I'm going to drop it over here. And you can see that now this is what we get, which is exactly the same image I uploaded over here, this image over here. But now we have these two buttons. One of them is original, which means this is the original image we have uploaded, and then the other one is called detections. And if I press this button, you can see that we are plotting the bounding box exactly on top of the tumor of this brain, right? I mean, I'm not a doctor, so I have no idea what I'm looking at. I have the impression this is a brain and this is an MRI, and based on the colors, I have the feeling that this is the issue, right? This is the tumor. So it looks like we have detected exactly what we should have detected, right? But this is the data I used in order to train the model, right? This is the training data. Now let's see if we have exactly the same performance with the data, with an image, in our validation set, right? This is completely and absolutely unseen data from my model. So let's see what happens if I just take a random image like this one. I'm going back here. This is the image I have just uploaded. Remember, now we are taking completely unseen data for my model. And let's see what happens if I move to the other tab, to the other button, which is detections, and we are successfully detecting the bounding box, the object we should be detecting in this image. So everything is working just fine. And in order to make it more challenging and more fun, let's see if we can detect an image with two objects. I know that there are a few, like this one, which has two objects. So I'm just going to drop this image here. And let's see if we can detect both of these objects, both of these issues. And we can see that we can detect both of them. So everything seems to be working just fine. And this is pretty much all in order to set up this web application up and running. You can see that we are uploading images and we are just detecting all the issues in this image, and we are just uploading everything exactly as we should. The only thing I'm going to do now is to use this other function we have over here, which is set background, right? The only thing I'm going to do is to change the background of this web application so we make it a little nicer. And this is exactly how I'm going to call this function. So I'm just going to main.py. I'm going to import from util, import visualize, and then set background. And then I'm going back to my file system. And this is an image I have prepared in order to change the background. It may not be the perfect background ever, but I think it's going to work. We are going to put this background in our web application. So let's see what happens. I'm going to copy and paste it over here. And now I'm going back to Python and I'm just going to call set background, and I'm going to input bg.png. And let's see what happens if I refresh. And you can see that now we have a much better looking background. So everything looks much better now. Now let me open a new image. I'm just going to select, for example, this image over here so we can see how the entire web application looks like with this new background. We have to wait a couple of seconds and now we are getting the image with all the detections on top. So this is going to be pretty much all for this tutorial. This is exactly how you can create an object detection web application using Python and Streamlit, and this is going to be all for today. If you enjoyed this video, I invite you to take a look at other of my previous videos where I show you how to make an image classification web application, and I'm going to be posting a link to this other tutorial over there. So remember, if you enjoyed this video, most likely you will enjoy that video too, because it's exactly the same process and it's a very similar web application. So this is going to be all for today. My name is Felipe, I'm a computer vision engineer, and these are exactly the type of videos and the type of tutorials I make in this channel. This is going to be all for today, and see you on my next video.